This lecture continues the work on normal distributions. As we know that if you have a continuous random variable, and if that variable is normally distributed, let's say x is a continuous random variable, then the distributions of this random variable can be illustrated using a bell-shaped curve. Okay. In this bell-shaped curve here, you have observations of random responses of this variable. All right. So then if you have a particular, or you have a certain value from this distributions from this random variable, let's say x1, x right here. So x1 right here. All right. Then using the bell-shaped curve, you can find the probability or the proportions of the entire populations that corresponds to this value, x1. You can find the probability or the proportions of the entire populations of this variable that is less than x1, right? You can find the probability of the proportions, the populations that is less than x1. So, right, which is this cumulative area here. Or you can find the probability or the proportions of the populations that is greater than x1. It's going to be this area here. So then how can you use normal distribution to find this corresponding probability or proportions of the populations? You can certainly use, remember in this previous lecture, we talked about the Z table, right? The table that gives you the idea of if you have a standard score, Z score, in a normal distributions, then you can find the probability to the left of this Z score. Or once you find the probability to the left, you can find the probability to the right by taking 1 minus the probability to the left. And Z score is a standard score for any value in the normal distributions. Okay. So that would give you the idea. Okay, so in order to find the probability, we need to convert the x here into its Z score. And the Z score for x1 is going to be x1 minus mu divided by sigma. Again, what is mu? As a reminder, mu is the mean of the populations, right in the middle of the distribution, and sigma is the standard deviations of this continuous variable, of this population of these distributions. Okay, so once you find Z, then you're converting x1 into z1, which is the standard score, and then you can use the z1 here and use the Z table to find the probability to the left of this value or the probability to the right of this value, x1. So you convert it to a standard normal distributions where you can use a Z-score. And in standard normal distributions, remember, mu is 0 and sigma is 1, okay? And then you found the Z-score. Z is 1 here. And you can use the Z table to find the area to the left of this z value, of the z value that you just found for your x value. All right, let's look at an example, word happiness. In a recent study on a word happiness, participants were asked to evaluate their current lives on a scale from 1 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The responses were normally distributed with a mean of 5.4 and the standard deviations of 2.2. Find the probability that a randomly selected study participant's response was less than 4. Okay. So if we read this scenario, we know that the responses were normally distributed. That means the x variable, the continuous random, the random variable is from, so the x, what is the variable? The variable here is the happiness scale, right? From 0 to 10. And we know that from the responses were normally distributed. That means we can use the bell-shaped curve in order to illustrate the distributions of the random responses. All right. And in this responses, we found that the mean is 5.4 and the standard deviations is 2.2. Okay. Now the question is, if you randomly select study participants, so if you randomly pick one response from all of the responses that you collected, say here, what is the probability that that random response will be less than 4? Okay, so where is 4? So 4 is here. 4 is less than the mean, so it should be on the left of the mean of the distributions, right? X is 4, it should be here. Okay, and then you're finding the probability to the left of 4 because you're finding the probability that a random response is less than 4. So you're finding this area right here. So in this area, you know that x1 is 4. Let's call a name like take x1 equals 4. Then from x1, again, in order to find the probability, you need to find z score. And z equals to x minus mu, right? Divided by the standard deviations. And it's gonna give you negative 0.64. I rounded to 2 decimal places because in the z table, the z values are at 2 decimal places. So 0.64, then from here, you can find the probability that you pick any x, right? That is less than 4 is the same as the probability that you pick any random z that is less than negative 0.64. And using the t table, z table here, you can find that again to the left, and your value is negative 0.64, which is 26109. 0.26109. So this is the probability that picking any random response from the population will be less than 4. Okay. How about what is the probability that you pick any random study participants' responses will be in between 4 and 6? again, we just want to draw a distribution so then you know which area you are supposed to find, right? So again, mu is still 5.4. And now the values of interest is from 4 to 6, right here. And you want to find the area in between these two variables. Okay. As we know that, so the area in between, in order to find the area in between, we take the bigger area to the left, subtract the smaller area to the left. So let's say, but the first thing we want to do, we want to find the z value that corresponds to each of the x values. We know that x1 equals 4, then z1 is negative 0.64. What about x2? x2 is 6. Then the z2 should be 6 minus 5.4 divided by 2.2. Which is 0.27. All right. So now again, the goal is finding the probability of picking a value that is in between 4 and 6. It's the same as the probability of picking a z value that's between negative 0.64 to 0.27. It's the same as the probability to the left of 0.27 minus the probability to the left of negative 0.64. Okay. And we already found that the probability to the left of negative 0.064 is 0.26019 in the previous section part. Now we just need to find the area to the left of this value. So z is 0.27. We're going to go to the positive sign. 0.27 should be 0.60642. Zero point 60642 minus 0.26019. Here. And the answer is 0.34623. All right, so this is for part B, part 2, between 4 and 6. This is your answer. How about the last part? When you want to find the probability, right, of selecting a random response that is greater than 8. So 8 should be here. And the mu is still 5.4. And standard deviation is still 2.2. Greater than 8, so we're looking at this area to the right of 8. All right. So again, we have another value. Let's call x3 equals 8. Then z3 should be equals to 8 minus 5.4 divided by 2.2, which is 1.18. Okay. And then you want to find the probability of picking an x value that is greater than 8 is the same as the probability of picking a z value that is greater than 1.18. And which is the same as 1 minus the probability of picking a value that's less than 1.18, which is 1 minus 1.18. Look at the z table. 1.18, 0.88100. And the answer is 0.119. All right, so you just found the probability that corresponds to difference values in these distributions. And we get the distributions from getting the responses from other study participants. And once you have other study participants' responses, you can build a distributions, and we know that it's normally distributed. We know the mean, we know the standard deviation, then we can typically, you can typically use this study, right? The result of this study to find the probability of picking a response that is in between certain values, less than certain value, or greater than certain values. All right. Let's go to the next example, utility bills. So the monthly utility bills in the city are normally distributed. So that we know that this variable, this continuous variable, is normally distributed. That means we can use the normal distributions, right? The z table, the bell-shaped curve, to illustrate these distributions. With a mean of 100 and a standard deviation of 12. So the mean is 100 and the standard deviations is 12. Okay, dollars is the unit of this variable. Find the probability that a randomly selected utility bill is less than $70. So the values of interest, right? The certain values is 70, and 70, x1 is on the left of the mean. And as we know that in order to find the probability, we need to convert x into z. Oh, 70. Which will give you negative 2.5. All right, once you have the z value, you can use the z table to find the probability. And in this case, less than, that means you need to find the probability to the left of this value. Negative 2.5 is 2.5 and 0. So 0.00621. So the probability, right, of x less than 70 is less than equals to the probability of z less than negative 2.5. And we found that is 0.00621. Is that right? Yes. Okay. So what does that tell you? That tells you if you randomly pick a household in this city, the probability of this household's monthly utility is less than $70 is very small. It's actually is only 0.6% chance that this household's utility bill, this household utility bill is less than $70. Very, very small chance. All right. How about what is the probability of picking a household whose utility bill is in between $90 and $120? So we do have mu is still 100, standard deviation 12. You have a different value of interest, which is 900, right? And $90 and 120. So as the car is x2 and this is x3. And you want to find the probability in between these two values here. Again, we have a new values. We need to find a new z. And x3 equals 220. So z3 is 120 minus 100 over 12. 100 divided by 12 is negative 0.83. And this will give you 1.67. We rounded to 2 decimal places. Okay. So again, the probability to the left, in between, is the same as the big probability subtract the smaller probability. So x is in between 90. Is the same as the probability of negative 0.83 in between 1.67. It's the same as the probability of z less than 1.67 minus the probability of z is less than negative 0.83. And which is the same as, so we need to find the probability to the left of 1.67. 1.67, 1.6. 7 is 95254. And negative 0.83. 0.830237. Two 0.0327. Okay, and then you just calculate this calculation to 5254 minus 0.20327, which you get you 0.74927. So what does that tell you? That tells you if you randomly pick a household in this city, then its monthly utility. There's 75% of the chance that the monthly utility of this household will be in between $90 and $120. 75%, which is pretty big. All right, how about more than $140? Again, you still have mu is 100, sigma is 12, but now your new values is 140. And you want to find the probability to the right, of this value. And again, we have the new values. Then we can find the new z. You get around 3.33. Okay. And then you can find the probability of X is greater than 140. It's the same as the probability of Z is greater than 3.33. It's the same as 1 minus the probability of Z is less than 3.33, which is 1 minus, what is 3.33? 3.33 is 0.00043. Well, I have to go to the positive one. It doesn't make sense. So 3.33 is 0.00057. 99957, which is the same as 0.00043. Okay. Again, the probability or the percentage of households whose utility bill is more than 140 is very, very, very small. It's 0.043%. All right. So using normal distributions and the z-tables, you can find the probabilities that corresponds to certain values that you're looking at when you try to analyze the data. One more thing that I want to emphasize is the way that you find the probability to the right of a value. So let's look at this last example here. So in order to find the probability to the right of this value, I used 1 minus the probability to the left of the z value. Another way you can do it is, because the distribution is symmetrical distributions, that means the area to the right of this value is the same as the area to the left of the opposite value on the other side. So we found that the z value here is 0.33. And then on the opposite side, the z value should be negative 3.33. So that means if you find the area to the left of negative 3.33, it will be the same as the area to the right of 3.33. So let's look at the area to the left of negative 3.33. We found it here, right? 0.0043 is the area to the left of negative 3.33, and it matches to the answer that we got from finding the area to the right of 3.33. So because, and this is a nice properties of normal distribution, because normally normal distributions is symmetric distribution. So this area here should be the same as the area here. Again, this lecture helps you find the probability that corresponds to a certain value in normal distribution.